You're going to be learning about the law of cosines and then how to solve oblique triangles using its formula. The law of cosine states that if you are trying to find a side, then what's going to happen is whatever that side is squared, you're going to have the other two sides squared added together minus 2 times the other two sides times the cosine of the opposite angle. Meaning, if you're looking for little a, then you're going to have the other two sides, which is b and c, and then it's going to be cosine of the angle A. If you're looking for little b, then you're going to have cosine of angle B. And if you're looking for little c, then you're going to be using the cosine of C. Now, these formulas look very weird. However, they are actually derived from the first three formulas. So, if you were to need to find an angle, these three formulas basically already have it solved for you to find the cosine of that angle. It is derived from over here. So if you were to subtract b squared and subtract c squared and then divide by a negative 2bc, then that would already get you the cosine of A. That is how you actually find this angle. So you do not necessarily need to know these formulas by heart because you can derive it from the original formulas. So when do you use law of cosines? Simple answer, when you can't use law of sines. Seriously. We've talked about the fact that you use law of sines if you have an angle and its opposite side known. So for example, if you have a triangle and you know that this is 30 degrees and you know that this side is 4, because you have an angle and its opposite side, you would use law of sines. This is law of sines. If you do not have its angle and its opposite side, then you have to use law of cosines. Now, the great thing about law of cosines is there is no ambiguous case. So when we talked about in law of sines to where you could have 0 triangles or you could have 2 triangles, in law of cosines that's not possible. You can only have 1 triangle. So let's do an example to prove how we can find little b. So we need to know this side. We do not have an angle and its opposite side, so we cannot use law of sines. So therefore, if we're trying to find little b, that means little a squared and little c squared is going to be on the other side, minus 2ac, whatever the letters are, it's going to be 2ac, and you're going to multiply that by the cosine of the opposite angle. If you're looking for little b, then you're going to be having cosine of b. So now let's plug in the numbers that we know. Obviously, we don't know b. We know that a squared is 16 squared. We know that c is 7 squared. And then we're going to multiply a, which is 16, and c, which is 7. And then we're going to multiply that by cosine of 95 degrees. When you type this into the calculator, you will get 324.522. I do not care at the moment of how many decimal places you use because we're still not done. That is b squared. We don't know b squared, we want b. So if you take the square root of that, you will get 18.01. Now that we know 18.01, now we can use it in order to solve for the other two angles. Now that we know little b, if you notice, we now have an angle and now we have an opposite side. So we actually do not have to use law of cosines again to find angle A. We can actually now use law of sines. So the sine of 95 degrees over 18.01 is going to equal the sine of A over 16. So the sine of A is going to give you 16 times sine of 95 divided by 18.01. So therefore the sine of A will give you 0.885. That's the sine of A. So in order to find the angle of A, you would do second sine of that number, and you will get 62.25 degrees, depending on where you round. Now that you know angle A, the last thing we need to find is angle C. Well, we already know angle B, and now we know angle A. So we can find angle C by subtracting angle B and angle A from 180 degrees in order to find angle C. Is 22.75 degrees. And now we have found all the sides and all the angles. We know angle A, angle B, angle C. We know little a is 16, little c is 7, and little b is 18.01. So the whole step is first, if you need to use law of cosines, go ahead and use law of cosines to find what you need. After that, you should have an angle and its opposite side, and in which case you'll be able to use law of sines to find the rest of the unknown information. In this case, this is different. We do not have an angle at all. So you actually can choose what you would like to find first. I am just going to find angle A first. It doesn't matter which one. I just decide to choose angle A. That means it is going to be A squared equals B squared plus C squared minus 2BC times cosine of A. Because if I wanted to find angle A, that means it's going to be set equal to little a. So little a is 23. So if we use that being A, that is B, and that is C, B is 29, C is 41, and then again we write 29 and 41. That is a 1. And then we do not know cosine of A. So what we're going to do is first subtract 29 squared. And when you subtract 41 squared, and we'll get 23 squared minus 41 squared. That is going to give us a negative 1993. That is equal to a negative 2378 times cosine of A. I had to multiply these together to be able to figure out the number that's in front of cosine of A. Now, to solve for cosine of A, I'm going to divide by 2378, and I will get a positive 0.838, because two negatives give you a positive. If that is cosine of A, therefore you will do the inverse in order to find angle A. So second cosine will give us 33.1 degrees. Now that I know angle A is 33.1 degrees, we now have an angle and its opposite side, and now we can find the other angles. It doesn't matter if you find angle C first or angle B first. We do know that, let's use a different color. We do know that the sine of angle A over little a is going to equal the sine of B over little b. And so therefore the sine of B is going to give me 29 times sine divided by 23. So we know that the sine of B equals 0.6886. So if I take the inverse of that, I will get 43.5 degrees. So now that we know that this is 43.5 degrees, and we know that this angle is 33.1 degrees, we can add them together and subtract from 180 to get angle C. So 180 minus 33.1 degrees minus 43.5 degrees is going to equal angle C, which is going to give us 103.4 degrees. So now we have solved for angle A, angle B, and angle C. Now, I showed you the long way of being able to solve for A. If you remember the formula that already has it solved for, then it would be cosine of A equals B squared plus C squared minus A squared over 2BC. So cosine of A would equal 29 squared plus 41 squared minus 23 squared, all divided by, don't forget the parentheses, you need to put parentheses around the top and parentheses around the bottom. 2 times 29 times 41. And you would get the same thing, I believe. And yes, you would get 0.838 if you can remember this formula. If not, you can solve it by hand. The biggest mistake that I see is that a lot of students go ahead and square 29 and square 41, and they go ahead and subtract that from 2 times 29 times 41. You cannot do that. This 22 times 29 times 41 is attached to the cosine. So this right here is one entity. You cannot subtract it from here yet. So let's test your knowledge. Which law would you use for each triangle? The law of sines or the law of cosines? So pause the video at the moment, see if you can figure out if you would use law of sines in each triangle or if you would use law of cosines. And then, then press play in order to see the answers. Okay, so for the first one, I know that we have an angle and we have its opposite side. So automatically, we would use law of sines. For the second one, we do not have an angle and its opposite side. However, you can find it. Since you know this angle and you know this angle, therefore you can find that angle by subtracting from 180. Once you do that, you will have the angle and its opposite side, which means, again, you would use law of sines. In this case, you do not have an angle at all, so automatically you would use law of cosines. In this case, you have angle B and you have little b. Since you have an angle and its opposite side, you would use law of sines. And in this case, you have angle X, but the other two are Y and Z. So you do not have an angle and its opposite side, so you would use law of cosines. So let's do one application problem that uses law of cosines. During a figure skating routine, Jackie and Peter skate apart at an angle of 15 degrees between them. So Jackie goes this way, and Peter goes this way. They say that the angle between them is 15 degrees. Jackie skates for 5 meters. Peter skates for 7 meters. How far apart are the skaters? So what we're wanting to know is this side right here. So if you use the A, B, and C, which is fine if you want to do that, that might be the easiest way. I'm going to assign this to be A, which means this will be little a. If this is B, then this is little b. And if this is angle C, then this is little c. So we're looking for little a. So A squared equals B squared plus C squared minus 2BC times the cosine of the angle that is being sought for. So we do not know A. B squared is 7 squared. C squared is 5 squared minus 2 times 7 times 5 times the cosine of 15 degrees. And you will get 6.385. Now, be careful. That is A squared. We don't want A squared. We need A, which means you need to take the square root. So the square root of that answer is going to be 2.53 meters.